Hello, good evening everyone. Welcome to BYJU'S Exam Prep. So I hope that my video and audio are absolutely fine. So let me know whether you are able to listen it properly or not. Yes. So according to me, it is good. So guys, today we are going to solve the questions of EMFT, and this is the top question series for the GATE 24, and here I am going to bring the questions from the subjects EMFT, and the topic would be for the ECE. So that is your plane wave propagation. Okay, the question will be from the plane wave propagation, and the question will be from the antenna. Okay, the question will be from the transmission line. The question will be from the waveguide. So these are the topics that I am going to cover in the today's session. So are you guys ready to solve the questions? Just let me know once whether you are ready or not, because here this is the questions that I am going to cover. So before starting the session, let me introduce myself. So this is Saket Verma, and I have done MTech from IIT Guwahati and cracked different PSU exam. And also, I have mentored more than lakhs of students for their preparation journey. And the subjects are electromagnetic theory, communication system, advanced communication system, signals and systems. So these are the subjects which I generally take, and you can ask the doubts regarding these subjects. So please share this session to all the other groups where you are, added up yourself, because this is the series where you will learn the new questions. We are going to solve not the old questions. We are going to solve the new questions that is not from any textbook. That is not from the any previous year GATE examination. So here you will come to know about the test, that how is your preparation actually. So I'm seeing the students are joining, and this is my telegram group. So if you are interested to connect with me for any other queries, then you can connect with me, and these are the telegram groups, advantage of adding up in these telegram groups. Okay, so you can add yourself in this telegram group, and before starting this session, I would also like to tell you that here we always conduct a scholarship test for the students. Those who are preparing for the gate are going to prepare for the gate, and in the 1st of October there is a 90% scholarship test we are announcing, and the window will be open from 9 a.m. to 9 p.m. You can register yourself in the link given in the description, and there is a 120-day strategy on 27th September workshop that is on today, and you will understand how you can get this one ace in the gate examination in the live interactive workshop. So yes, so now still the students are joining. So let's start the session. Good evening, Balaji. So this is the pure EC based questions that I am going to ask. So if you are already prepared with the EMFT subject and want to test yourself, then this is the session for you where you can cover up your maximum topic for revision. So I am giving you 3 minutes to solve every questions. So take your time, but solve it correctly. Don't be in rush. I am giving you 3 minutes full time to solve this problem. Yes, everyone, quickly solve this session. We have 2 minutes time, and within this 2 and 3 minutes, you have to answer this question. Come on. So you have 2 minutes left. What should be the answer of this question? An airfield square waveguide is given. Yes, Reena Singh has given the answer. Engineering Babu, good evening. Birju, answer this question. This is the question from the waveguide, and this is the mixed questions where we are discussing the questions of EMFT and from all the topics across all the topics other than the electrostatic and magnetostatic. I am not keeping that because I have already taken the two sessions for that. 12.5 gigahertz. The first answer I have got from the Reena Singh. We have 1 minute left, so I am waiting for the other students to answer this question. So 30 seconds left. What should be the correct answer as I have got the first answer as 12.5. Anyone else who wants to answer this question? This can be done in the 1 minute also. Those who know the concepts can solve in the 1 minute also. Yes. Reena, good evening. How is your preparation? कैसा चल रहा है तैयारी यार? इंजीनियरिंग बिरजू, रीना, कैसा चल रहा है आपका प्रिपरेशन? चलो, तो देखो यहाँ पे आपको कट ऑफ फ्रीक्वेंसी निकालना है ना। कट ऑफ फ्रीक्वेंसी का जो फॉर्मूला है वो होता है एफ सी इज इक्वल टू वीपी अपॉन टू। ठीक है, प्रत्युषा भी ज्वाइन कर ली। 25 गीगाहर्ट्ज आंसर आ रहा है। एम अपॉन ए होल स्क्वायर प्लस एन अपॉन बी होल स्क्वायर। ठीक है, ये हमारे पास फॉर्मूला है। अब आप देखो कि इसमें आपको कैसे वैल्यू मिलेगी। यस, सो बिकॉज स्क्वायर वेव गाइड है, ए और बी की वैल्यू सेम होगी। और एग्जैक्टली प्रत्युषा हैज गॉट द राइट आंसर एक्चुअली, because this is the a equal to b. Here a is equal to b, and from this particular expression you can understand this is the y component, so you will take m equal to 0 and n equal to 2. So this is the mode we have from this particular expression of the electric field. So now because it is air field, so we will take c upon 2, and both are same, so this is m by a whole square multiplied with 2. Okay, so it is equal to c upon 2 into m. What is the value of m is 0, so we have to write n. So n is, oh, okay, sorry, wait. I have done one mistake, small mistake. Yes, m is 0, so m is 0 and n by b whole square, and n by b whole square. So here outside the root we will be having n by b. C is 3 into 10 raised to power 8, and because it is in centimeter, so let's write in the centimeter. So in the centimeter per second, the velocity of light is 3 into 10 raised to power 10, and n is equal to 2, and this is 2, and the b, that a is equal to b, so it is 1.2. So this 2 and 2 will get cancelled, and here you will get the 30 upon 12, which is 2.5 into 10 to the power 10, or you can write it as 25 gigahertz. So right answer is 25 gigahertz. This is the square waveguide, so A and B would be same, and this is the expression of the electric field, so don't consider the dominant mode. Okay, so those who have considered the dominant mode, maybe they are getting the answer as 12.5, because C upon 2A is the dominant mode frequency, and here it is 3 into 10 to the power 10 divided by 2 into 1.2. So here you will get this 15 upon 12, so 1.3025. Okay, and into 10 to the power 10, so you are getting 12.5 gigahertz. This calculation is wrong because of the dominant mode. This is only for the dominant mode, but here we have, okay, here we have the mode is TE02 or TM02, whatever you want to write, TE02. Okay, got it now? Those who have got the wrong answer, yes. Pratyusha, यस रीना, समझ में आया आपको कि आपने क्या मिस्टेक किया है? 12.5 रैंडमली आपको चूज नहीं करना है। ओके, रैंडमली आपको चूज नहीं करना है 12.5। दिस इज वेरी इंपॉर्टेंट क्वेश्चन एक्चुअली। जिसके पास थोड़े कॉन्सेप्ट्स क्लियर नहीं है वो जस्ट डोमिनेंट मोड के लिए निकालेगा और 12.5 निकाल देगा। बट आंसर जो है हमारा 25 है। तो बेसिक क्वेश्चन है बट काफी यूजफुल है टू अंडरस्टैंड योर मिस्टेक, जनरल मिस्टेक दैट यू डू। Last 44 seconds. Yes, so the time is up, guys. Before moving to the next question, solution of that question, I am giving you one more question. Then I will tell you the solution of both question together. Okay, the solution of both question I will give you together. Yes, Bhanu and Ratusha has got the answer. Now answer this question. Okay. Last 1 minute. Check your answers. Those who have got the answer, because the time is left, you can just cross check your answers. Okay, just don't sit idle. Once you have done with your solution and if still the time is left, then cross check your answer. So it will give you the habit of cross checking your answers. Suppose you are solving 20 questions, then at least if you have time, then a 10 question also, if you can review, then you can be sure that your that 10 questions are 101% correct, and the remaining 10 questions, obviously it may be a 90% chances made it may be correct, because if you have marked it, that means you have got the correct answer. So yes, Bhanu has got the answer A and Pratyusha has got the answer D. So let's see that are who is actually the correct. Okay, who has done this as the right one. Yes, so the right answer is linearly polarized. As you can see that the amplitude of Z component is not equal to the amplitude of Y component. So it can be either linear or it can be elliptical. So it can be linear or it can be elliptical. But for elliptical, there should be some arbitrary phase, but in case of linear, the phase difference should be integer multiple of pi, and there is no phase difference in between them. So here the phase difference is 0. So the phase difference is 0 here. Okay, the phase difference is 0, hence the answer is linearly polarized. Right, Pratyusha? So there is no phase difference between the Z component and the Y component. E to the power minus j beta x, e to the power minus j beta x, both are same. Now coming to this part, here we have calculated that an air-filled rectangular waveguide has a dimension A is equal to 2 and B is equal to 1. Then the range of frequency over which the guide will operate in a single mode. So what do you mean by the single mode? That means the waveguide should operate only in the one mode. So for that the operating frequency will be, it should be at least one mode, means obviously the dominant mode, and it should be less than the next higher mode. What will be the next higher mode? The next higher mode will be TE20, because here the A is equal to 2B condition is satisfied. So it can be the TE20 or it can be 01 also. Both will give you the same answer. So here the if you calculate the FCTE10, so it is C upon 2A. So it is equal to 3 into 10 to the power 10 divided by 2 into 2. So it is 30 upon 4, so 7.5 gigahertz. Okay, and then if you calculate FCTE20, then it is C upon A, which is 3 into 10 to the power 10 divided by 2, which is nothing but a 15 gigahertz. So the operating frequency should be in this range for the operation in the single mode. So answer is option C. Okay, these are the two questions. Now coming to the next question. No idea? No idea about the relaxation time? So the relaxation time is relaxation time tau r is epsilon upon sigma. Here we want to calculate the sigma conductivity. So epsilon upon tau into r. Epsilon is 6 into epsilon naught divided by tau r 54. So epsilon naught upon 9 and epsilon naught is 8.854 into 10 raised to power minus 12 divided by 9. So it is just zero point 0.9 something into 10 raised to power minus 12. So answer should be option C. Okay, the answer will be option C. Now solve this one. A wave propagates from the dielectric medium to interface with free space. If the angle of incidence is the critical angle, then the relative permittivity of the medium. Come on, answer this question. Bhanu, Katyusha, what happened? Why you guys are not able to solve this question? D, A. And the right answer is, yes, D. The right answer is D. Okay, so what is the critical angle? So critical angle is sine theta C is equal to the second medium refractive index divided by first medium refractive index. Okay, this is the formula. And what is the refractive index? That is nothing but the velocity in vacuum. Okay, velocity of wave in vacuum divided by velocity of wave in medium. So according to this, the velocity is c and the velocity is vp in the medium. So it can also be written as c upon root over mu r epsilon r. So mu epsilon and C mu r epsilon r. So here the C and C will get cancelled, so it will be mu r epsilon r. So now you can write this as second medium means your dielectric. So this will be root over epsilon r. Mu r we are considering 1 and this is air. So sine 20 equal to root over epsilon r. So epsilon r is equal to sine square 20. Is it or something different? Tell me. What is your first medium? It is, yes, exactly. It is opposite. Okay, it is opposite, right? This is a wave propagates from the dielectric to air. So this means the first medium is dielectric. So this is root over epsilon r2 and this is 1. So now that's how I have done. Yes, that is the mistake, Pratyusha. Yes, that is the mistake. That's why I also write in the same way so that you will understand what is the mistake actually happening with the understanding of the question. Okay, the understanding of the question. That is the first medium is dielectric, second medium is free space. So first medium will be root over epsilon r1 and the second medium is 1. So now you will write sine 20 equal to 1 upon root over epsilon r1 and hence you will get epsilon r1 is equal to 1 upon sine square 20. Okay. So from here you will get epsilon r is equal to 8.54. 8.54. Yes, from it is written as na from. That's what we generally we do the mistake, and this type question wordings we have framed in that way only that the many students will get confused with that. And remember one more thing that the generally the relative permittivity or relative permeability both will not come less than 1. First, this thing also you should keep in mind. If you are getting less than 1, that means you need to cross check because there are very rare material for them the relative permeability and permittivity are less than 1. Another question from the waveguide only. So answer is 482.94. Yes. Banu. 489. Why this much difference? Let's check. The cutoff frequency is already given. So intrinsic impedance, which mode? TE mode. So in case of TE mode, eta TE is eta upon root over 1 minus FC upon F whole square. Okay, so eta is because it is air filled, so we will take 377 and divided by root over 1 minus cutoff frequency is 25 and it is 40. So whole square. So it is equal to 377 upon root over 25 upon 40 whole square. So it is 482.94. Why the answer is so much different, Pratyusha? This is the exact answer I am also getting. 4.6. 4.6। चलो चेक करते हैं आपका आंसर। यस, 4.6 इज द एब्सोल्युटली राइट आंसर। प्रत्युषा, दोनों का आंसर सेम आया है। ठीक है, ऑब्वियसली ये ब्रूस्टर एंगल है, तो ब्रूस्टर एंगल में भी हम लोग को मीडियम चेक करना होता है। सो टेन थीटा बी, और ये पैरेलल पोलराइजेशन है, रूट ओवर सेकेंड मीडियम का और फर्स्ट मीडियम का परमिटिविटी एप्सिलॉन आर टू डिवाइड बाई एप्सिलॉन आर वन। तो यहाँ पे ये टेन स्क्वायर 65 इक्वल टू एप्सिलॉन आर कितना हो जाएगा, फ्रॉम द वेव प्रोपोगेट्स फ्रॉम एयर। सो एप्सिलॉन आर मुझे निकालना है, एप्सिलॉन आर टू एप्सिलॉन आर वन। सो टेन स्क्वायर 65 ही आपको डायरेक्टली कैलकुलेट करना है। सो टेन स्क्वायर 65 आपका आना चाहिए सेम जो आप बोल रहे हो। ठीक है, टेन स्क्वायर 65। यस, 4.6 एप्सिलॉन आर टू इज इक्वल टू 4.59 आ रहा है। इसको आपने अप्रोक्सीमेट करके 4.6 बोला है। ठीक है, करेक्ट है। चलो नेक्स्ट क्वेश्चन पे चलें। सॉल्व दिस वन। Yes, I am from ECE. Can I choose only CS branch paper? Is it possible without choosing two paper combination? No, no, it is not possible. Amrendra, your graduation degree, one paper should be from your graduation degree. First paper especially. First paper should be from your graduation degree, and the second you can choose whatever the branches are eligible according to the gate brochure. The combination, they already provide the combination, na? They have already given the brochure. In the brochure you have seen that what are the subject combination that in which you can give the gate examination. So according to that you have to prepare. So what is the answer for this question? Magnitude of magnetic field at that location. First of all, because it is a conductor, calculate the value of eta. Okay. So first of all, you calculate the value of eta. Eta is equal to root over omega mu upon sigma at an angle of 45 degree, because it is a conductor. So what is omega? Omega is 2 pi into 500 into 10 to the power 6 into mu. Mu is 4 pi into 10 to the power minus 7 divided by sigma, which is 10 to the power 6 at an angle of 45 degree. So you got 500. Now 500 is not the right answer. So from here, because we want to calculate magnitude only, so no problem. Here we want to calculate magnitude only, so you can ignore this angle also. So this 10 to the power 6 will get cancelled. One pi will be outside, and this is 10 to the power minus 6, so 10 to the power minus 3, and 5 into 2, 10, 40,000. So yes, what is the value of this? Can you calculate it and tell me what is the value? Root over 2 pi into 500 into 4 pi into 10 to the power minus 7. 0.0628. Are you also getting 0.0628? Yes. 0.0628. Now the electric field is given. We know that eta is equal to E upon H. So from here you can calculate the value of H, which is E upon eta. E is your electric field. 2 microvolt is given. So 2 into 10 to the power minus 6 divided by 0.0628. So we need to just divide it by 2 divided by 0.0628. This is 31.84 microampere per meter. 31.84 microampere per meter. This is the answer. Correct? Just don't take up to 0.06 only. Just take some more values, because after decimal first is if 0, then at least you should go for two decimal digit after 0. So 0.63 also you could have taken, and then you will get the exact 31.84. Yes, you have to pay for both the paper. Amarendra, you have to pay for both the papers, because when you want to appear in the two different examination, then you have to pay for both of the paper. So 1500 each for one subject. A lossless transmission line is terminated with a load which reflects a part of incident power if the VSWR is 3, then the amount of power that is reflected back. 25%. Okay. Bhanu has got 25%. So VSWR is 3. So this is given as 1 plus mod gamma divided by 1 minus mod gamma, or you can also calculate the mod gamma value from S minus 1 divided by S plus 1, which is VSWR. So 3 minus 1 upon 3 plus 1, this is 1 upon 2. So this is 50, and the percentage power reflected, the percentage power reflected is given by mod gamma square into 100. So it is 1 by 4 into 100 equals 25%. So answer is 25%. Now answer this one. Any answer? Only 1 minute left. 30 seconds in fact. Reflected electric field. Okay. Okay, so now first of all we will calculate the incident electric field. Okay, so incident electric field is nothing but the EI naught and cos of omega t minus beta z and the incident electric field direction. So how do you calculate? It is in the free space. So first of all, this EI naught will be eta naught, which is in the free space, and HI naught. Eta naught is 120 pi. Okay, so let it be 1 eta naught only because all the options are given in the eta naught. So this is 40 eta naught. What about omega and beta? Beta we will calculate. So beta is equal to omega by c. It is free space. So 10 to the power 8 and divided by 3 into 10 to the power 8. So it is 1 by 3. Okay, and then we have the electric field direction. So electric field direction is direction of magnetic field cross product with direction of propagation. So direction of electric field is magnetic field is AX cross AZ. AX cross AZ is minus AY minus AY. So in this way you have got your incident electric field. I am writing here for reference. Incident electric field we are getting 40 eta naught cos of 10 to the power 8 t minus z upon 3 and AY with minus sign minus AY cap. Yes, Akansha Vasisht has got the answer as C and Pratyusha has got answer as B. Okay, so first of all, this thing we have got. Now we want to calculate the reflected electric field. So for that we need to calculate the reflection coefficient, and the reflection coefficient is eta 2 minus eta 1 divided by eta 2 plus eta 1. So it is 120 pi root over epsilon R2, mu R2 divided by epsilon R2, mu R2 divided by epsilon R2 minus 120 pi divided by 120 pi root over mu R2 divided by epsilon R2 plus 120 pi. So this 120 pi will get cancelled, and this is 5 and 2. 5 and 2 it is given, so root over 5 by 2 minus 1 divided by root over 5 by 2 plus 1. So how much it is? 0.225. So we are getting 0.225. Okay, 0.225. So now the reflected electric field will be in this way. Electric field peak value cos of omega t plus beta z, and the direction will remain same minus AY. So this is 0.225 into incident wave. Incident wave is 40 eta naught. Cos of omega is 10 to the power 8t, and beta is for the reflected medium. So reflected wave, that means in the first medium itself. So 1 by 3 only, z and minus AY. So how much it is? 900 only. Yes, 0.9 only. Eta naught cos of 10 to the power 8t plus z upon 3 and minus AY. It is 9 milli. Okay, it is coming 9. Okay, so it is coming 9. So our final answer is minus 9. Yes, Bhaskar, good evening. Minus n naught cos of 10 to the power 8t plus z upon 3. Okay, so in this way we have got this answer as option number B. Yes, Bhaskar, I am good. So guys, if you want to download our BYJU'S exam prep app, then just go and download from the link given in the description, because the link which is given in the description are open for all of you, where you can download and you can access our free content as well. Okay, our free content as well you can access. You will get the 20 free lectures, from whether it is from the paid course, whether it is recording, whether it is a free sessions. You can watch 20 sessions. So if you have any doubt in any particular topic, then also you can download your the BYJU'S exam prep app and watch that particular lecture, because you have access of 20 free lectures. Okay. So thank you for this session, guys, and thank you for joining. Yes, I can no, you cannot choose primary paper as CS as per my knowledge, and this is the question as a homework. You can take this as a homework. Okay, you can take this as a homework. And don't forget to join our course. Full course is also there 2025. 2025 course if you are one, and a 2024 crash course. So you can join for get 2024 also, get 2025 also, and you can get the live classes, recorded classes, etc. And guys, remember that tomorrow at the same time. Okay, tomorrow at the same time, 4 p.m., I will be bringing again one more 10 to 15 question series of the EMFT. There also the question will be from the transmission line, plane wave, waveguide, antenna. All these four topics will be covered. Okay, all the four topics will be covered. So tomorrow at the same time, 4 p.m., just set the reminder. And today at 5:30 p.m. Today at 5:30 p.m. in the app, okay, in the BYJU'S exam prep app, you can have the test on digital circuits. Okay, you can give the test on digital circuits at 5:30 p.m. Today at 5:30 p.m. in the BYJU'S exam prep app, you can have the digital circuit test. Okay, so don't miss these sessions. Thank you.